Let's look at problem 13.2. Chapter 13 is all about taking a graph of something we know and then changing it in various ways. I know you guys have done this before. You shift things right or left, you dilate or compress them, reflect them about the y-axis or the x-axis, and I think that's all. But you can do stuff in the y direction and the the other way around. Y direction and the x direction. So you shift both ways. Yes, I think you've done that before, and then let's go over some examples to remind you how to do these things. So first, they just made up this function and said that's f of x. That's our function. So we don't know what formula it is. It's not even one given formula. It's whatever it is. That's what it is. So then they say, okay, come up with a new function that's 2f of x plus 1. What would that look like? Okay, so we take this one and we do 2f of x plus 1. Okay, so that's part A here, 13.2 part A. Okay, so first, step one is we look at this and first we shift it. If it's plus 1 to the x, that means it shifts to the left. It's always the x's are always opposite and the y ones make sense. And that's because if we solve for x, we would put x is equal to minus 1 on the other side. So it makes sense it's kind of opposite. So we're going to shift this whole thing left one. So what I would say is write the rules. First, you look at the shifting part to the x, and then we're going to shift it to the left one. So I'm going to go like this, shift it to the left one. Okay, now we're not multiplying the x by anything. If we had multiplying by the x by 2, we would compress it by 2. It's always the opposite for the x. Instead of making 2 bigger, it's 2 smaller. But it's not, so we don't have that step. And the next step we have is now the y, since it's outside the function, the y is multiplied by 2, and the y ones always make sense. If you multiply by 2, it's 2 times bigger, so it gets 2 times bigger. It is dilated is the word I think they say, dilated by 2, as opposed to compressed by 2. So you can look at this graph and you can say, okay, it's going to be 2 times taller. Well, actually, first we shift it over 1, and then we make it 2 times taller. Every single y value is multiplied by 2. I'm not going to be able to fit it on here because if I multiply by 2, it's going to go, well, I guess I could go way up there or something. Or here, let me scroll down a little bit so I can fit it on there. Let's see, okay, something like that. Okay, so all the y values multiplied by 2. So I'm going to take this one, make it 2 taller. Oh, wait, no, first I got to shift it over. That's hard to do. So that point goes over 1 to here. This point goes over 1 to there. This point goes over 1 to here. This goes to there. And so it's going to look something like, it's hard to draw the exact graph, right? This point here goes over 1 to here. So it looks like this and like that. And then, let's see, it goes up to here. So it looks like it goes kind of like this. And then it goes down to like that. Okay, that's the shifting to the left by 1. Now we got to go double all the y values, which is even trickier. So this doesn't look like a nice peak there like that one. Oh well. So then it goes to somewhere up here, and this one goes to somewhere right there. This goes down to here. This stays the same. If it's on the 0, the y value is 0, that one stays the same. So this one goes down lower. Okay, so I'm going to do this in green now, so it's going to look something like this. Like that. 0 stays the same, but now it goes up really high and comes down to here. That 0 stays the same, so it hits down there and then goes down to here. Okay, that's what it would look like. That's hard to do. It's hard to graph, do that over and then make it taller and everything. So instead, what you are welcome to do for these, because it can be hard to graph these, is instead look at the major points. Okay, so this is which is still a lot of work. Maybe you just want to graph it, but let's look at the major points here, the ones that we can shift. So there's like 1, 2, 3, 4, 5. So let's look at, oh, I don't know, they labeled that one. Let's look at 2, 3. Okay, so 2, 3, that's our point. The first step we already said it's shifted to the, all these we're going to shift this way 1. That's the x value. We take away 1. So minus 1 in the x value. And then we're going to multiply the y value by 2. Okay, so the y value gets multiplied by 2. So we take away 1 from the x. That makes it 1. And multiply the y value by 2. That makes it 6. So that point goes to 1, 6. So 2, 3 goes to 1, 6. Then, what are the other points? Okay, I should have drawn this up here. So this way, negative 1, the x direction, y direction multiplied by 2. Then, the other important points, let's look at negative 1, 1. So negative 1, 1 goes to, take away 1 from there, so it goes to negative 2, comma 2. Multiply the y value by 2, take away 1 from the x value. Let's look at this point, 0, comma 3, comma 0. So 3, comma 0. Take away 1 from there, it goes to 2, and 2, and multiply the 0 by 2, and it's still 0. The zeros always stay the same because when you compress them, obviously when you shift them, the zeros change. But compressing or dilating stay the same. So that goes to 2, comma 0. Okay, so if you do all the major points, then you can just plot those new points and connect them. Maybe it's a little bit easier. I don't know. All right, let's look at some of the other ones. The next one is we take this shape again, and we want it to be 1/2. So our new function is 1/2 f of 2x minus 1. 2x minus 1. Okay, so let's figure out what we do with this. Okay, no matter what the function is, what do we do with 1/2 f of 2x minus 1? What is our rule? So first, we look at what's multiplying by the x. It's multiplying by 2. That's the first step. Actually, no, it's not. Yeah, in this case, no, it's not. First, you shift it. Sorry. First, you shift it. Since it's minus 1, you shift it to the right. To the right by 1. It's always, so we add 1 to the x. It's always the opposite, right? Take away 1, minus 1. Okay. Then, so our second step is we dilate it. And in this case, we compress it because, again, we're multiplying by 2. The x direction is always backwards. So we divide it by 2, or multiply it by 1/2, right? Dividing by 2 is the same as multiplying by 1/2. So we're going to, x direction. We're going to compress it in the x direction. So I draw it like that, compressing it. Shrink it down the x direction by 2, or multiplying it the x direction by 1/2, times 1/2. Then in the y direction, we are multiplying it by 1/2 also. We're compressing it by 1/2. The y direction is one you have to do anything about. Oh, it's 1/2. We make it 1/2 as big. So times 1/2 in the y direction also. So all our points, whatever they are, this is what we do. So let's look at one of them, like 2, comma 3. Okay, what happens to our point 2, comma 3? We're going to add 1 to the x. So it becomes, and by the way, if we do more than one step in a direction, it's good to do each step at a time, right? I could do it in my head. But first we add 1, and then we multiply it by 1/2. So let's do it in our heads. If we add 1, we get 3. Then we multiply it by 1/2, so it's 3/2. So the point 2, 3 goes to the point 3/2. Add 1, 3 divided by 2. Yep, that's right. And the y value, we only do one thing to the y value, so that's easy to do in our heads. We multiply 1/2, so it's also 3/2. So the point 2, 3 goes to 3/2, 3/2. Let's do another point. Let's look at 3, 0. Okay, 3, comma 0. We add 1, make it 4, multiply by 1/2, that'd be 2. So it goes to the x value 2, then the y value, we just do one thing, multiply it by 1/2, it's a 0, 0 by 1/2 is still 0, so that point goes to 2, comma 0. So again, what you do is you take all the most common points, the major points that you know, figure out what happens to them, and then you can plot them, and then you connect them, making the shape of the curve about what it should be. Okay, let's look at the last example. It is It is 5 times f of 1/2 x of 1/3 x plus 2 minus 2 of 1/3 x plus 2 minus 2 plus 2 minus 2. Okay, so the order is important. The first thing we do is we shift the x. You always start with the x's, you work your way to the y. So you always shift the x first. If there is an x to shift, if there's not, then we do the compression one. But we have an x to shift, 2. So it's plus 2, so it goes this way, 2, or we take away 2 from the x value. Okay, this is the extra, so take away 2. Then, if we're dividing by 3, that makes it 3 times bigger, right? It's always opposite. Instead of 1/3 is big, it's 3 times bigger. So we dilate it. You go like this. We make it bigger in the x direction times 3. 3 times, looks like should be 3 times smaller, which means it's 3 times bigger. Then in the y direction, we multiply it by 5. And that's what we actually do. So it's going to be, in the y direction, it's going to get times 5, 5 times bigger. And then we take away 2. Again, the y direction, it makes sense. If we shift it 2 down, that means we go down 2, or we subtract 2 from it. So every point, we do this. So let's again take an example point. Let's take our point 2, 3. First, we take away 2, which is 0. Then we multiply by 3. 0 times 3 is still 0. So this point goes to 0, and then the y one, 3 times 5 is 15, minus 2 is 13, so it goes to 0, 13. Well, that's going to be pretty high up there. It's going to be hard to graph. All right, let's look at another one. Let's look at the point -1, 1. Okay, take away 2, -3 times 3, so it goes to -9. And the y value, times 5, 1 times 5 is 5, minus 2, 5 minus 2 is 3. So it goes to -9, 3. And then again, you do this for all the major points, you plot them and you connect the dots. Okay, that is how you shift, dilate, all that kind of stuff. Now, the order is really important. Okay, so first step you do is you do the x's. First, you shift the x, then you dilate it. So the order you go is first you shift the x, then you dilate the x. Then, if it's negative, let's say this was a negative there, then you reflect the x. After that, you make, okay, x is positive. Oh, now we make it negative. Okay, so if this was it, if it's -1/3 x, after we multiply it by 3 and everything, we go, oh, we should make it negative now. And so if it was -9, we would make it positive. Actually, these two, it doesn't matter what order you do. You could reflect it, then dilate it, multiplying and making it negative. It's the same thing. So that doesn't matter, but you might as well just choose an order that works. That works. Okay, then on the y values, then you dilate the y. That's this thing, dilate or contract it. So I'm going to say dilate, but it could be a contraction. I guess a contraction is a negative dilation, right? That kind of works. Then you reflect it, reflect the y, and that'd be if there was a -5 there. Then the y becomes a positive. So like here, if that was -5, we added 3, it'd be -3. Okay? And then you finally, the last thing you do, the 6th step, you can read it all the way down here. Can you read it all the way down here? Nope, almost. Is you shift the y. That's the last thing you do is you shift the y value. And again, these two actually don't matter. The dilating and the reflecting doesn't really matter which one you do first. They end up getting the same thing. But might as well choose an order. Dilate, reflect. Shift, dilate, reflect. Dilate, reflect, shift. That's the deal. Okay, so that is how you do those. All right, hopefully that makes sense.